Hello, welcome to my channel. In this video, I'll be talking about projectiles. Projectile motion refers to the motion of an object thrown or projected into the air. It's subject to only the acceleration of gravity, and the path taken by a body in projectile motion is known as trajectory. It is typically parabolic in nature. Let me show it in a diagram. Projectile motion is a kind of motion that you have when you throw something. Let's say you throw a stone, okay? From let's say this is ground. When a stone is thrown, it's follow a trace like this. Okay, this is projectile motion. It is typically under the influence of gravity. So the acceleration it usually has is a downward acceleration due to gravity. Okay, and usually when you are dealing with calculations in projectile, the path taken, this part is the trajectory. Usually, when you are dealing with calculations in projectile, there are some assumptions, and these are the three assumptions. Usually, there is no air resistance, acceleration due to gravity is constant and acts downwards, and also the heart curvature and rotation are ignored because if you take them into account, the calculation will be slightly different. There are key quantities in projectile motion, and this include the time of flight, which is the total time the body spent in the air. Let's say the body is thrown like this. Total time it spent on the air is the time of flight, and the maximum height is the height it attained before it starts coming down. Okay, that's the maximum height. And the horizontal range is distance from where it is thrown to where it's landed, or the horizontal distance. That is the range. Okay. Projectile motion actually has two components. And if you look at the path of the projectile motion, like this, the two components are the vertical axis and the horizontal axis. Okay. Usually in projectile motion, the body usually is projected at an angle alpha to the horizontal, and this is usually given in the calculation. So when you are dealing with it, the way to deal with it is to look at it in two components. The y component, which is the vertical component, the vertical component, and the x component, which is the horizontal component. When you are doing calculations in projectile motion, you still use the same equation that we use in linear motion. The three equation, let's remind ourselves, v equals to u plus 80. The second equation is v squared equals to u squared plus 2as. And the third equation is s equals to ut plus 1 over 2 at squared. You can watch my video on linear motions and equations of motion. I explain how these formulas are derived and what each of them stands for. When you want to do calculation in projectile motion, you use the same equation, but you need to understand the different components of a projectile motion, and we are going to look at them now. We'll look at the vertical components and the horizontal components. Okay, the vertical components, let's say this, we'll look at the vertical components and the horizontal components. And for each of these components, we are going to look at the different parameters here vis-a-vis the final velocity, the initial velocity, which is u, the acceleration, which is a, the t, which is time, and the s, which is the displacement. Okay. Now, let's first of all look at the initial velocity u. The initial velocity u in a vertical axis, in a vertical component, is usually, you need to resolve the, when the body is projected, it's usually projected at a particular velocity. Let's call it velocity v at an angle alpha to the horizontal. Okay, so what you need to do is to resolve this velocity along the vertical axis for you to get the initial velocity along the vertical axis. On the resolution of vectors, you can watch my video that I did on resolution and resultant of vectors. You will see it up here. The link is up here. Go to it and watch it for understanding or resolution of vectors. Now, to get the initial velocity along the vertical component, you resolve the velocity along the vertical component. And before I go, I want you to take note of something. In trigonometry, cos 90 minus alpha is the same thing as sine alpha. You can check that out in your trigonometry. Okay, so I will be using sine alpha. If I were to use cos 90 minus alpha, I would rather be using sine alpha in the following equation. Okay, now for you to resolve this velocity along the vertical axis, don't forget that this is a right angle triangle, and since this is alpha, this place will be 90 minus alpha. Okay, now, if you want to resolve it along this axis, that will be v cos 90 minus alpha, which is the same thing as v, the velocity, okay, the initial velocity, sine alpha. Remember what I said here, okay? So, this gives us the initial velocity along the vertical component, that's the y component, okay? Let's call it uy along the vertical component. Okay, along the horizontal component, which is ux, will be equals to, you resolve it along this direction. Okay, which is the horizontal component, that will be v cos alpha. So this is the initial velocity for both of them. Okay, for the both the vertical and the horizontal components. Okay, now the next one we'll talk about is the acceleration, which is a. Acceleration along the vertical axis is usually the acceleration due to gravity. When the body is going up, it will be minus g, and we know that g is a constant. G, acceleration due to gravity, is a constant, which is approximately 10 meter per second squared, right? So when the body is going up, it will be minus g. When the body is coming down, it will be plus g. Okay, now, in the horizontal components, there is no acceleration for a projectile motion. So, acceleration is equals to 0. Okay. Now, the next thing we will talk about is the final velocity, which is v, the final velocity of a projectile motion. Okay. Usually, when the body is thrown up like this, it goes up and at a point it stops momentarily. Okay, and at that point, the velocity along the vertical axis, the Vy, the final velocity along the vertical axis, is usually equals to 0. So therefore, the final velocity of a projectile motion along the vertical axis is usually 0, and that's the point at which it starts coming down. Okay, for the final velocity of a projectile motion in the horizontal axis, it's usually the same as the initial velocity because there is usually no acceleration. So Vy here is equals to 0, and Vx is equals to is the same thing as the initial velocity, which is the resolution of the velocity along the horizontal axis, which is v cos alpha. Okay, good. Now we've taken care of this. We've taken care of initial velocity. We took care of the acceleration. Now let's look at the time. The time taken for the body is can be calculated from the equations of motion. And we usually consider the motion along the vertical axis for us to calculate the time to reach the maximum heights, which I will call th, time to reach the maximum height, which I will call th, and the total time of flight, which I will use, which I will represent with capital T. Now, how do we calculate the time to reach the maximum height? The time to reach the maximum height is calculated using the first equation of motion, the equation 1, which is v equals to u plus at. Okay, we know that along the vertical axis, the vertical component now, if you want to calculate the total time of flight, you have to consider the motion, the vertical component of the motion. Okay, and in the vertical component, we are using this formula now. Please take note, we are using this formula, which is v equals to u plus at. Okay, and in the vertical component, v, the final velocity, is equal to 0. Okay, good. And the initial velocity is usually this, v sine alpha, v sine alpha. Okay, that's the initial velocity, plus, don't forget that at the points that this body is going up, the acceleration will be minus g. Okay, so that will be minus g, which is the a here. A will be minus g, okay, times t, which we want to calculate. Okay, so this will be equals to v sine alpha minus gt. So from there is equals to 0. If we bring this to this side, our final calculation will be t, the time to reach the maximum height now, which is th. Let me put it there. The time to reach the maximum height will be equals to v sine alpha divided by g. So this is the time to reach the maximum height, th. Okay. Now, for us to calculate the total time of flight, the total time of flight will be equals to the time to reach the maximum height and the time to come down to the level from which it started. And since the time it takes to reach the maximum height is usually the same as the time it's used to come to the same level, the total time of flight will be equals to the total time of flight will be equals to 2 times the time to reach the maximum height. Okay, so this is the time to reach the maximum height. Okay, hope you got that. Now, on the horizontal components, the time to travel from here to here will be the same thing as the total time of flight. Okay, the total time of flight, okay, is the time to travel this range. Okay, so now we've taken care of this. Now we've taken care of the t, which is this. Okay, now let's move on to take care of, we don't have enough space here again. Let's move on to take care of the time to the maximum height, which will be represented by h. The maximum height, to calculate the maximum height h, we are going to use the formula. Let's look at the formula. Which of the formula can we use here? We need to use a formula that has s, which is the height, right? And the time and other parameters that we know. Okay, and if you look at it, we should be able to use this formula: v square equals to u square plus 2as. So we'll be using the formula v square equals to, sorry, we'll be using the formula v square equals to u square plus 2as. And now, when we want to calculate the height, we are considering the motion in the vertical component of the motion, right? So now, in that case, the final velocity will be equals to zero, okay, which is zero squared, okay, is equals to the u, the initial velocity will be equals to u sine alpha square, which will be u square sine, okay, u sine alpha squared, okay, and our a will be minus because at that point the acceleration is going up, so it will be minus 2g h, which is the maximum height that we want to calculate. And making h subject of the formula here, we'll be able to get h, which is the maximum height, will be equals to u square sine square alpha divided by 2g. Okay, this is just the mathematical evaluation. Okay, so this will be the maximum height. Okay, now in the horizontal components, we want to calculate the range, which is r. Okay, what is the formula that we would like to use here? In this case, we will be using the formula s is equals to ut plus half at squared. And don't forget that when you are considering motion in the horizontal axis in a projectile motion, the acceleration is usually zero. So this will sum up to zero. So we'll be left with s equals to ut. That's what we'll be using. And in this case, our s will be the range, r will be equals to u, which is the initial velocity, and the initial velocity along the horizontal component is v, that is, this is it, v cos alpha, okay, so times the t. Now the t here will be the total time of flight, which is equals to this one, which is equals to this 2 times t, total time to reach the height, which is equals to this. So that will be that will be 2, that is total time of flight, 2v sine alpha divided by g. You wonder where it comes from? It comes from this. We said the total time of flight is 2 times the time to reach the maximum height, and the time to reach the maximum height is equals to this. So I just put 2 here. That's why it become 2v sine alpha. Okay? If we evaluate this equation, it will turn out to be the range will be equals to the range will be equals to 2v squared 2v squared, okay, cos alpha sine alpha divided by g. So this is the formula to calculate the range of the projectile motion. Okay, so I hope you understand this. If you don't understand, you can watch it again. And if you still have problem understanding my explanation, you can comment in the section below so that I will make a special video to understand it more. Okay? Now, the projectile that we considered in the previous slide is the projectile that is launched from the same height. You can recall it is launched from the same heights that it's landed. Okay. Now, what about if the projectile is launched from an height? Let's say someone is standing here, okay, and he launched a projectile that come like this and land here. Okay. So, how do you take care of that? It's simple. What you just need to know is that the motion for this type of projectile is of two parts. The first part is the part that is used to travel from here to the same level where it was projected. That is the first part. And the second part is the part that it's used to travel from the same level it was projected that it's reached after it has reached the maximum height to the ground level. Okay. So once you know that, now what you just need to know is that if you want to take care of this motion, any calculation you want to do, you compare it in these two parts. The first part is this, the second part is this. And the first part will be taken care of using the same strategy that we used here in the first uh, slide, in the previous slide that we did. And the second part will be taken care of using some assumption, right? It is still a linear motion and the three equation of motion is still very much relevant. Okay. Okay. So what you just need to know is that at this point, the initial velocity is usually the same as the initial velocity with which it was thrown from here. Okay, along the vertical axis. If this is alpha, you know, the velocity along the vertical axis is v sine alpha. That's the same velocity that it will have when it is coming down like this. The vertical components now. We are taking care of the vertical components. Okay. So that is v. The sorry, the initial velocity with which it was thrown here along the vertical axis will be the same initial velocity that it has here along the vertical axis. And you know the initial velocity along the vertical axis here is what? Is equals to the initial velocity along the vertical axis here is v sine alpha, and this will be its initial velocity when we are considering the second part of the motion. Okay, and its and its the final velocity can be calculated using this formula. That is the velocity at which it hits the ground can be calculated using this formula. Okay. Now we've taken care of the initial velocity and we've taken care of the final velocity. We can take care of the height too, the height from this place to this place. Okay, if we are given the time. And the acceleration will be equals to g because it is coming down. Okay, it is coming down, it will be accelerating. So If you put all these things together, you will be able to calculate the total time of flight, which will be equals to the time of the first part, the total time of the first part, which we dealt with earlier in the previous slide, and the time it's used to travel from here to here. You add it together, okay? And in that case, you can actually calculate it using this formula, in which t will be equals to v minus u divided by a. Okay, so this will give you the time to travel from this level to this level. Then you add it to the total time of flight it used to travel from here to here, which was what we dealt with in the previous slide. Okay, so that will be plus the time it used to travel in the first part, which is t. Okay, this will give you the total time of flight. Okay, now the horizontal range it's used to travel, the horizontal range it travel will be the same as the horizontal range, the same formula that we used in the earlier part, which is this is the same formula that you are going to use. What you just need to take note of is that the t that you will use here, let me write it for you. You know, we said the range will be equals to s equals to ut plus 1 over 280 squared, and we say this will be 0, so it will be s equals to ut. Okay, and the s will now be equals to u, which is v cos alpha along the horizontal components, because that's what we are considering now, times the t that you got here. Okay, that's what you are going to use. And don't forget that this t is equals to the time it's used to travel here, the first part, and also the second part. Take note of that. And the maximum height is usually the same as it was done here, but you should take note that you need to add the height here, okay, plus the maximum height that is travel here, which you use the formula that we used in the previous slide, which is this one. So when you add it together, it will give you the total height, h plus h. Okay, to give you the maximum height from the ground. You should take note in the question that you are given. If you are asked for the total height from the ground, you are going to add it together like this. But if they say the maximum height from the point of throw, then you are going to use just the h that we calculated from this place. Application of projectile motion. The projectile motion has several applications in different endeavors of human life, in sports, military, engineering, and space sciences. So take note of all this. You may be asked uh, in the exam. And in sports, the optimal angle for throwing a javelin or shooting a basketball. If you look at the equations that we used, you will realize that you need to get the maximum, the angle that will give you the maximum value, the angle whose you need to get the angle whose sine alpha, product of their sine alpha and cos alpha will give you the same thing. And if you look at that, very likely is angle 45. Okay. So, and also in analyzing soccer, in the military, when they use missile and rockets, the trajectory analysis is done to ensure that the location, the target is appropriately hit. So this it has its application in the military and also in engineering and space science. Launching of satellites, the application of uh, projectile motion is very much evident in that. Now let's go through some questions to test our understanding and also to reinforce some of the things that we know. The first question: a projectile is launched with a speed of 50 meter per second at an angle of 45 degree. Okay. What is its range? If you can recall, the the formula for the range is h is equals to 2v squared sine alpha cos alpha divided by what? Divided by g. If this is r, that's the range. Okay. If you input the formula, you should be able to get it. Okay. Which launch angle yields the maximum range? The launch angle that used that is the maximum range is, if you look at the formula, what I said earlier, range equals to 2v squared sine alpha cos alpha divided by g. For this thing to be maximum, the maximum value that you can get for this, since we know this one will be constant, this one is constant, we'll be given this, we'll be given this. The only thing that varies is this, okay, sine alpha cos alpha. Anything, any of the angles that you multiply, and when you multiply them together, it will give you maximum value, is what will give them the longest range. And if you check that, it's 45. A ball is projected horizontally from a height of 20 meters. How long does it take to hit the ground? They say it was projected from an height of 20 meter and it was projected horizontally. When they say horizontally, it means the angle here is 0, right? And it hit the ground. So for this body, the velocity along the vertical components, don't forget, will be v sine 0, and sine 0 is 0. Okay, so along the vertical axis will be 0. Now along the horizontal axis, it will be cos 0, which is equals to 1, right? Cos 0 is equals to 1. So to be the velocity, cos 0, which is equals to v, right? Good. Now, since there is no, since the initial velocity along the vertical axis is 0, the u here will be equals to 0. And when you know u and you know the height which it will fall, then you can use the formula. Which formula are we going to use now? We are asked to calculate how long it will take. That's the time. So we must have a formula that includes all these things, and that is s equals to ut plus 1 over 2 at squared. The s is the height it will travel, which is 20, is equals to the u is 0 t, which will be 0 together, plus 1 over 2 at squared. Okay, so this will be 40 is equals to, and don't forget the a is equals to g, because it is coming down, it is accelerating, right? The g is plus, right? That will be 40. This is how I got 40. These two come to multiply this, half times 10 times t squared, right? Sorry, this one is gone already. So 1 times 10 times t squared. So t squared will be equals to 40 divided by 10, right? And t will be equals to root of 4, which is equals to 2. Okay, so the correct answer is 2. They say a projectile reaches its maximum height in 3 seconds. What is its initial vertical velocity? Its initial vertical velocity can be gotten when we use the equation of motion, which will have the time and the initial velocity and final velocity, right? So When you use v equals to u plus 80, what we want to calculate is its initial velocity, right? And the final velocity, we know it will be equals to zero, because when it goes up, at the final moment before it comes down, v will be equals to zero. So this is equals to zero, okay? And u is what we want to calculate the initial velocity, okay? And a will be minus g because it is going up like this. So a will be equals to minus g. So this will be minus gt, okay, which is equals to gt equals to u, and t is equals to, sorry, and u will be equals to 10. G is equals to 10 approximately, although it's 9.8 meter per second. You can approximate it to 10 for the ease of calculation. Okay, times 3 is equals to u. So u equals to 30 meter per second. So grabbing 29.4 meter per second. Don't forget that we approximated it to 10. Okay, so if we had used 9.8, if you multiply this, it will give you around 29.4. Okay, they say a projectile is launched at 60 degree with speed of this. Find its range. You can use the formula that we derived earlier. Okay, 2v squared sine alpha cos alpha divided by g. You get the answer. What happens to the range if the launch angle increases beyond 45 degree? What happened to the range? Still from that equation, range equals to 2v squared sine alpha cos alpha divided by g. What happened when the value of alpha increases? What happened if it increases? The range, don't forget that the range is the distance from where it was thrown to where it's landed, like this, right? So if the angle here increases, you know, what will happen? It will not be able to reach it again. And if it's increasing, it will come here. Okay? So the range will be what? Will be decreasing as the angle increases, especially beyond 45 degrees. Okay? A ball is projected with a velocity of 30 meters per second. What is the maximum height if launched vertically? So, if launched vertically, it means the whole of the vertical axis has the initial velocity. Okay, so this is very straightforward. Okay, we know the final velocity will be zero. We can use v square equals to u square plus 2as. Okay, and the maximum height will be h, right? So the final velocity will be zero, is equals to, since this is the whole of this velocity is in vertical component, is in the vertical axis, and is launched vertically. Okay, so that will be u squared, that is 30 squared, and since it will be decelerating, that will be minus 2gh, right? And this will be, if you bring it to this side, that will be 2gh equals to 30 squared will be 900, right? Good. So h will be equals to 900 over 2 times 10, right? Is equals to 90 over 2, which is equals to 45 meter. Okay, the answer is this. A projectile lands 200 meter away after 4 seconds. What is horizontal velocity? Let me leave this one for you to do. If a projectile's range is 100 meter and time of flight is this, what is its horizontal velocity? I believe you should be able to do this. Okay, I'll leave the remaining for you to do. Please kindly like, subscribe, and share. It takes a lot of effort to make this video, and I'll appreciate it if you can appreciate my effort. You can encourage me to make more video by just simple click like, subscribe, and share for others to benefit. Okay, I'll see you in the next video. Bye bye.